Hi, this video is a supplemental video to the instructable I've made, which explains how to build this wooden race car track and the electronics behind it. This wooden track was built by my friend Dan here, and then I did the electronics on top of it. This is me on the left in the gray shirt. This track has been a ton of fun. We raced it for New Year's Eve, spent several hours on it, and the kids had a blast, the adults had a blast. We raced Pinewood Derby cars, Lego cars, all sorts of stuff down this track. They were even rolling balls down it at one point. The thing that makes it special is several things. One is the track comes apart, and here's a side view of it. My buddy Dan put this powered by Faro Industries, which is very flattering on the side. But you can see right here, if you look right above this P, you can see the track has a split, and this is where it comes apart. This is one of the sections, and the legs here also are removable. We'll get into that in a bit. This is the top part, and it shows the pegs that basically hold the cars up, and this is the starting, basically the starter right here. If you turn this, the pegs go down, the cars go down the track. This is the score timer. This can be shown on a television, a tablet, a cell phone, basically anything I can navigate to a web page. It's really nice on a big screen TV when you're doing races. Then the whole family or friends can see what the times are and everything. It shows the lane, the place of the cars. This is a race that's in progress, so you can see that it says racing. And then when everything is done, it shows an average mile per hour. This is all customizable, this entire web page, and I'll go over that in the code walkthrough. If you haven't seen the trailer video for this or the instructable, I recommend starting there. This is going to be the longer kind of walkthrough to get you those that want to build this through the code, or those that want to customize it, or those that are building the electronics that want to hack or mod it. This is the video for you. This is going to go pretty much into a deep dive of everything. So I'm using OneNote to kind of walk through this. Bear with me as I navigate this, but I think it'll be the easiest way to get the most information to you. I want to start with the electronics, and I'm going to start with the old fritzing diagram. I spent 45 minutes on this diagram. I didn't spend 45 minutes wiring the whole thing, so I kind of got frustrated with this. I couldn't find the sensors that I needed. And anyway, what I'll do is I'll just talk through this, and then I'll show you the actual sensors. The electronics on this are very, very basic, and I'll explain where these fit in. But what you've got is pairs of sensors. So for each of these on the right, these three here, you've got two wires. And you can imagine these as almost infrared flashlights. These two wires just have to give them power. These go under the track and they face up. The other three on this side face down and they receive the light. If something gets between the light that these send and the light that these receive, it gets blocked and it sends a signal. You can tell the receivers because they have three wires. They have two that go to power, and then they have a third wire that you wire onto your Arduino board. Now this Arduino is the Adafruit Huzzah ESP8266. The ESP8266 is a very powerful Arduino compatible Wi-Fi chip. Matter of fact, it was created to give Arduinos Wi-Fi back in the day over serial. But what we use it for is to take the sensor data, read it in, and serve out a web page. These three sensors, one of them will go under each lane, one will go above each lane. There are three pairs here. And outside of that, there's only one other electronic component that we have to worry about, and that's this button right here. This button gets hit by your starting system. If your starting system, when you build this track, if you go with ours, it's a rotating knob. When you rotate the knob, you have a dowel. Slam this button here, and that will start the race. As the cars cross these sensors, it'll finish the race, and I'll show what that looks like in a second. I'm going to move on to focus on the sensors themselves and to talk about the wiring to show you the two wires versus three and give you some notes. So here's what the sensors look like. This is one sensor wired up to a standard Arduino Uno. This is the more your classic Arduino. This isn't the Feather Huzzah. But that being said, it'll help us understand the logic of how these are plugged in. You see here, this one here only has 2 wires on it, red and black. This one has a red, a black, and a yellow. The red is a positive terminal on these. The black is negative on both of these. So what you want to do when you're wiring these up is connect all of your reds together and all of the blacks together. Run your blacks into your ground, your reds into your positive. You're going to want to run them into 5 volts. These sensors work with 3.3 or 5 volts, but if you give them the higher voltage, you'll get a bit better range, a bit better accuracy on them. Since we're running off a Feather Huzzah, we can run it off the VCC line, and it'll pull 5 volts off of the USB that's coming in. This is how the sensors are arranged. There's, again, this one, the 2 wire is sending, the 3 wire is receiving. If something gets in the middle of these and blocks it right here, then this will send a signal to whatever pin this is plugged into. In this case, following this along, it looks like it's pin 4. We actually use pins 12, 13, and 14 on the Feather Huzzah. These are the sensors up on Adafruit's site, $1.95 each. You'll notice that the 3 wires here, there's a white wire. The reason I show this is when you order these, the wiring diagrams you get may not match up, and so I want you to realize that you can tell what the signal wire is by just using red and black to eliminate. If there's a red, black, and yellow, yellow is going to be your signal wire. Red, black, and white, white will be your signal wire. So whatever that 3rd wire is, that's going to be your signal. You can use red and black for power. Okay. Now this is the finish gate at the end of the track. The top's open on it, showing the electronics that fit in this box. And what I want to do is just kind of show, this is really, when I talk about these sensors, this is where they're going to get mounted. If you look at the bottom here, I'll try that in a different color. There's 3 holes on the bottom. The sending sensor, the 2 wire sensors, are underneath here, facing up. The wires run along the side, up a hole along the side here, and then into the box. Up here on top are 3 more sensors facing down. These are the 3 wire sensors, and they're hooked to the Arduino, which is in here. These sensors must line up with these holes down here. So when you're connecting them, make sure that you get the sensors to line up, and then hot glue them in or connect them however you want, but basically make sure that they don't move again. You can also epoxy them in. The main concept you want to understand is this is forming a beam basically from here to here. And as the car comes down, it breaks the beam, and that's what actually triggers the endpoint and tells it, hey, lane 1, a car went by. Stop the timer for lane 1. One other thing I want to note, we're going to talk about the track in a second after we do a code walkthrough, but the track comes apart. So the other thing you need to understand about wiring is you're going to want to use Molex connectors. Molex is these plastic connectors here, and you can get 2 wire connectors. These wires are running from the end of the track all the way up to the top where the start is, where it hits that button. The other thing to note is this brass connector here. This is just a note for when you're building the track. This is a locking system. I believe this is a cabinet latch that is used to hold the tracks together. So if you imagine the track, this is looking at it from underneath. And then finally, this was a brilliant just wiring trick right here. This is just a way to keep the wire connected. And notice he connected it right at the split. And then you can have the Molex connector connect the wires and then run them in further. And what this does is when the track comes apart, it keeps the wires nice and tight to the wood so that they're not dangling around loosely. This being designed for kids to take apart and all, having a good design here will help this last a lot longer. I'm going to go into a code walkthrough, and then I'll talk about the track. When we talk about the track, we'll talk about the wood and how things get put together and such. The code walkthrough, there's 2 things I want to focus on. One is things that you might have to customize. What I did is I highlighted these in yellow. This is anything from pins on the Arduino to timeouts and such like that. The other thing I wanted to do is highlight in green things that are interesting that I want to bring up to help you debug or not run into the same issues I ran into when I created this initially. So first things first, at the top, I tried to get all my variables up at the top. I didn't quite get them as cleanly as I'd like, but highlighted yellow here, you can see that most of them are up top pretty high. Lane pin 12, 13, and 14, this is where the 3 sensors are hooked in. If you add a 4th sensor, you're going to want to add another lane pin, and you'll want to work that into the logic. Right now it's based around 3 lanes. And there's a number of racers 3 here. I actually forgot to highlight this. Oops, that's not a highlight. But basically here, number racers 3, you'll want to increment that if you add a lane. These lane pins are important because this is where the sensors are hooked up. You got to be very careful on this. If you hook it up to pins 2 or 0, you'll get very wonky results. The Arduino may not boot anymore. The reason being is we're going to pull these pins high. That's the way those sensors work. You pull them high, and then when they get crossed, they go low to say that something's in their way. So if you use so let's say pin 2 and you pull it high, then it may tell the Arduino not to boot anymore. This is a behavior at 8266, I believe. So anyway, I had a lot of problems. I was trying to start off with low pins. I decided to go to higher pins and change my pull-ups, and things worked a lot smoother. Start button pin here, this is where your, switch markers again. This one right here is where your start button gets wired to. I wired 2 buttons to the start button pin, and then I pull it up also. Just an easier way to do it. You can do three wires and do a pull down with a resistor to pull it to ground. I just didn't want to run 3 wires all the way up and down the racetrack. Max race time in seconds. A lot of Lego cars, when they race, they crash. And because of this, they don't ever finish. So I needed some way to tell the timer at some point to give up on cars that weren't going to cross. The other scenario is if you race one car on 3 lanes, you don't want to have the race go forever. So you want a timeout where it says, hey, if no cars cross in this many seconds, they're never going to make it across. I chose 7 seconds. This is in milliseconds. And I want to point that out just in case you're doing racing and your cars are slower, or if you decide this timeout isn't worth waiting, if you think it's too long, this is where you want to edit it. So it's the 7,000 right here. This IP address is the IP address you have to navigate to get the private website. You go to http 10.10.10.10 and you'll get this web page. I did 10s because I thought it would be easy to remember and nice and clean. You can change this to something else if you'd like, if you think that would be easier. This is a bit advanced, but just I want to mention it since we're up here. This DNS server.h, and you'll see some mention of captive portals and this DNS port. What I'm trying to do here is I'm trying to basically DNS hijack anything that somebody tried to navigate to when they were connected to the Wi-Fi access point and redirect them to the web page for the racetrack. The idea behind that was it would make it super easy to use. If you connected to this Wi-Fi, there's only one web page being served, so anything you typed in the address bar, it would go here. It didn't work out great. It's not very reliable, but I wanted you to know why the code's there. I left it in because it's reliable enough to be valuable right now. Moving down a bit, this int scale 64 is assuming a Hot Wheel scale. If you're doing Hot Wheel cars, it'll assume 1/64th scale. This is used for calculating the speed of the cars. I calculate it in a Mach mile per hour. My calculation is very naive and I'm sure wrong. I did some analysis and some reading to try to figure out how people calculate scale speeds, and it got quite complicated. Some people were talking about, like, do you scale down time? Some people were talking about, like, the point of the observer. Anyway, if you want to do scale and you want to make it very reliable, you're going to want to change this value as well as change the algorithm, which I'll point out later. If you're just having fun for kids and they just like seeing things like their car went 264 miles an hour, I would just leave this alone and have fun with it. The input pull-up on pin mode here, if you read a lot of Arduino documentation, it might just mention that set the pin as high, and that will turn on the internal pull-up resistor. I was not having luck with this. However, I found some documentation about this input underscore pull-up. When I changed it to that, the pull-up resistors all worked, and my readings on my lanes went from very unreliable to perfectly reliable. So I just want to point that out. This is a difference. If you look at how to use the sensor, the tutorials, you're going to see something different for how they turn on the pull-up resistors than the 8266 that I used. This is an important one. This is what the Wi-Fi hotspot will show up as. Latent Lanes is the name of the lane that I gave it with my buddy Dan. If you want, you'll probably want to change this to whatever you want to name your racetrack. And that's a really cool personalization thing that's very easy to change, and it'll show up on their phones when or whatever you're connected to Wi-Fi. They'll see the access point, and you can have a lot of fun with that. Serial printing, I like to highlight this one in green. If you're doing coding, heavy coding on this, and you're doing a lot of debugging, if you turn on a lot of serial printing, while it's printing out the spew, it's not reading the sensors. So it will miss cars as they go through. So you'll see that I don't use serial output much on this. That's why. Just be careful. I don't want you to hit the debugging episode I did where I spent hours trying to figure out why the cars were no longer triggering the sensors, and I kept adding more serial print lines to debug it. Web server on not found. If they navigate to a page and it's not found, then this should trigger. And what it does is it'll call get.html, which outputs our website. This is the last main bit of code I want to go over. And mainly because there's so many things here that you can configure. This is your website. This is a website that'll show. So I'm going to go back to the intro and show the website again. And then we'll line this up. So let's see here. So this is the website. And you'll see the latent lanes and powered by Faro Industries here. This is the title and subtitle. And then you'll see the 3 lanes highlighted in orange. If you look at the code here where it says latent lanes, powered by Faro Industries, these are the lines you would want to change to make that your own racetrack name. Also up here in the title, this one isn't as important, but it's another one that you can change to be more customized to your racetrack's name. If they add the page to favorites, this is where this is going to show up. The web page, once it's navigated to, say they navigate to it on a tablet or on a TV, every 20 milliseconds it refreshes. If you're familiar with HTML or JavaScript, you're going to see the set timeout function, basically calling to set the location of the window over and over again. And here's the 20. If it seems like it's refreshing too fast or not fast enough, you can tweak this and see if you get better results. All of these colors here, I mentioned the instructable, another website to get different colors, or if you know hex, you can calculate your own. This is where all the colors for the website are done, is in this HTML. You see I've highlighted a couple of them. So anytime you see the number sign or the hashtag and 6 digits, this is going to be the first 2 are red, second 2 are green, the third are blue. And it's 0 through F for each digit here. Basically, you can do a little bit of research, a little bit of search engine work, and you'll figure out how to calculate this on your own. And you can change the colors of this. Right here is the debug spew. If you want to clean up the look of this, if you want to get rid of this debug series down here, you can remove that. I recommend leaving it in for a while, just because it's super useful if something goes wrong or if you have something blocking one of the sensors on a lane. It's really handy to have that debug spew. But if you want to maybe make it smaller or change it, that's where you would change that at. Okay, moving on down the code. This here is the scale speed formula. This is some horrible math that you'll want to change if you really care about scale speeds. I think I found a forum post and decided it was good enough and went with that. And it seems to be fun for the kids, so I went with it. But if you want to get actual speeds, you're going to want to know stuff like how long your track is in inches and calculate it, or centimeters, and then do the calculations based on that. I'm not going to get too into the code. I commented it. I feel like it's pretty self-explanatory, but very basically, there is a mode, and the mode is either 0, 1, or 2. If it's 0, the race is not started yet, and you're going to see the hit button to start, and that shows up. That shows up here where it says racing. That'll say hit button to start, and that means that this is at 0. Ooh, sorry. If it's 1, then the race has started. That means that the knob has been turned, it hit the button, it goes into racing, and then it waits until either all 3 cars have crossed the sensors or the timeout hits, and whatever happens first, it'll change it to case 2. It'll say finished, hit button, reset. When you hit the button, it'll go right back down to racing. It just restarts the race again. You see again, here's a serial debugs commented out. Turn these on. Be very careful. You might lose the racing. Basically, the race tripping the sensors. Max race time in seconds. This is the timeout where it happens. Please do not edit it here. Edit it above where it's defined. But I want you to be aware where the logic is for the timeout. At the very bottom here, you'll see a code boneyard. This is old code that I tried to use. This is the old pin mode input to set them high. I'm sorry, actually right here. Digital write high to turn on the pull-up resistors. This was not working for me, but I wanted you to know where it is. This code here was for debugging the speed, so you can cut and paste that back up there if you are having problems getting your speeds right. And it also shows where I got my source. Be very, very careful when you're calculating speed. If you do a division and a car has not finished yet, you may end up with a divide by 0 error, and that will crash your microprocessor. It'll crash the Arduino. You'll have to reset the entire thing. Okay, finally we're going to go through the track. This is Dan when he was building the track. Again, Miami Dolphins fan. That's where the color scheme came from that we use for the scheme that we're shipping. You can see the track getting put together here, the splits in it. And then this is the track when it's taken apart. There's one other piece of the track that's not shown here. It was on the table. We were actually actively working on it. It's the end piece, but this shows how he designed the legs and the legs fitting together, which is really nice. Notice also here he's got a divot in the wood for that's for this round dowel, which is really nice. And then that dowel, these are the gates. Basically, you turn the dowel, the gates go down. At the same time, when you turn the dowel, the start button gets hit. So there's a dowel on the back of here that I don't have a photo of that goes, and then you've got a button. So when this rotates around, it hits the button. Again, showing the side view. This is the making of, I'm going to kind of show the making of the pegs that connect the track together. And keep in mind, Dan did all of this work. I'm just using his photos and talking over them, so I won't be as detailed, but if you ask questions in the forum, we'll get you answers. Or I'm sorry, on instructables.com, we'll get you answers. If you, what he's doing here is he's cutting the steel bar, and he's building these pegs here. And then he's using, not only is he building these pegs, you can see each of the pegs that are in here, but he's got these cabinet locks to lock it together. And that combined makes it very easy and secure to put this together. And then also it's pine, so it's very, very lightweight, so the kids can do it. And he rounded it so that it's not too sharp, but it's sharp enough to guide into these holes. Now these holes had to be very exact. And so here he's showing that he had a jig to drill the holes in. So a little bit of woodworking skill there, but you know, it's well worth it. I haven't seen a track that comes apart and goes together like his, and it's really cool to not have a 15-foot track that you have to have all the time take up your living room. He can break it down into small pieces. Here he's showing, this was really clever. He put it in the drill to sand it down, help it fit into the holes. And this is an early view of the track coming together, and this shows the molding. So you can see the molding pieces here that were used, and then also he routed some pine board and ran it down. You just want to make sure your lanes are all even. Match it up to whatever you're going to race down it. His is great because I really love that you can run Pinewood Derby cars down these, as well as Lego cars, as well as Hot Wheel. They all ran pretty well down there. We even ran, I think, Micro Machines down it at one point. And the only thing they have to do is on the other end, they have to just cross those little holes and the sensors will trip and you'll get a time. This is a focus here on the top. This is showing the pegs. I had pre-circled this in another run through. And so, I mean, I've already got the arrow here. Basically, you turn this handle, and he did a beautiful job creating these handles. Turn that, the peg goes down here. The button is underneath right here. And then there's a peg coming off the back of here that comes up and hits the button. These go down, the cars get released, the timer starts, and then you just catch them on the end line. Thanks so much for watching. I hope that was helpful. The project was a ton of fun, but I really underestimated, of all the things in the project, how much fun we would have actually playing with it at the end. The adults and the kids were into it. We were building Lego cars for hours. Things ran solid. I feel really good about the software. And I feel like it's a pretty doable project by anyone from Cub Scouts on up. If you're very much into electronics, you can add some lights when you do like a red, yellow, green for the starter and do a servo. You can automate the starting part of it. You could add sound effects. Like, there's quite a few things that you could add to this. It's very hackable. All of the sources out there available on Instructables. My alias on Instructables is JFARRO. It's my first initial last name. You can look me up and find this project and other ones I've submitted. Thank you so much for watching. I try to reply to any comments that have come in, any questions. You can leave them on either the YouTube channel or on Instructable, and I will answer them and help you out. Happy making. Thanks.